So when you're solving exponential equations, we have 3 steps, okay? Since they don't have any logs, we don't mess with any logs or anything, they just have exponents. So the first step is look for a common base. Now with exponents, the base is the big number. With logs, the base is the small number. So we're gonna start with the big number. We got 2 of them. We got a 6, and we got a 216. Those are the bases, okay? And then the little numbers are the exponents. Okay, so common base. So what I mean by a common base is a base they share in common. If I was to break them down, what base would they have in common? Okay, so when you're doing that, I'm not talking about a GCF. Okay, not talking about a GCF. I know GCF is one thing. We're not talking about a GCF. We're talking about a common base. Okay, so does anyone know what bases they have in common? Kind of, yeah, when you break it down. So I know you can divide both of them by 6, but that's a GCF. I'm not talking about a GCF. I'm talking about a common base. So let's say 3. Is 3 to some power going to give me 6? Like 3 to the first power, 3 to the second power, 3 to the third power? No, right? 3 to the first power is 3. 3 squared is 9. So 3 won't work. Let's try 2. That's why I kind of wrote on the board 2, 3, 4, 5, ... whatever it takes. So can I write 6 as 2 to some power? 2 to the second power, 2 to the third power, 2 to the fourth. Can I write 6 as one of those numbers? No, that doesn't work either, because 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. So 2 doesn't work. There's only one way to make 6. That's why I started with this question, because there's only one way to make 6. What to what power? 6 to the first power. There's only one way to do that. Okay. Now, is there a way to make 216 with 6 as a base? There is. 6 to what power? Third power. Yep. 6 to the third power. Now, I changed the way the numbers look, but I didn't change the number. 6 to the first power is still 6. 6 to the third power is still 216. You don't believe me? You could go to your calculator and figure it out, right? I just changed the way they look. It's kind of like if I have a $20 bill and someone gives me 2 10s instead. It's still the same thing. They just look different, right? Instead of a $20 bill, it's 2 10s. So it's the same thing. I didn't change anything. I just changed the way they look, okay? That's the first thing. So the common base is going to be 6, okay? Bring everything down I haven't used. So I haven't used the exponents yet. So this is still 3x minus 3, and this is still 3x plus 1, okay? Simplify. Second step, simplify exponents. How do I get rid of the parentheses? What's the rule for getting rid of the parentheses when you're dealing with exponents? Yeah, multiplication, right? Distribute. If I have a power to a power, right? I have 6 to the first power to another power, and then 6 to the third power to another power. I got to distribute. So that's what I'm going to do. I'm going to distribute my powers. So I got to distribute to both parts of the exponent because it's 2 parts. It's a binomial. Okay. So I'm going to get 6 to the 3x minus 3 when I distribute the 1. And then when I distribute the 3, I'm going to get 6 to the 9x plus 3. Okay, that's step 2. I'm going to stop right there for a second. Now I'm here. They're equals. Each side is equal, right? How do I know that? Because they gave me an equal sign. If the bases are the same, what has to be true about the exponents? They also have to be the same. They have to. Otherwise, they wouldn't have written that equal sign. Okay? So what I'm going to do is, the last step says, set the exponents equal to each other. Set the exponents equal to each other. Now the 6's, what happens to the 6's? They're still there, but they're already equal. So I don't need to set them equal to each other. The 6 and the 6, I already know they're equal. I already did that. So I'm just focused on the exponents right now. So set them equal to each other. Okay, so 3x minus 3 equals 9x plus 3. And solve. How do I solve this equation? Am I going to use my trinomial steps or my binomial steps for this guy? Set it equal to 0 and do all that stuff? No, not for this guy. This guy doesn't have an x squared. There are no x squareds anywhere. There are no x squareds. Okay? So how we solve these is we draw a line and get x on one side, get a number on the other. Okay, so we're going to subtract 3x from both sides. Then I'm going to subtract 3 from both sides, so I get an x on one side, a number on the other. So I have 6x over here, negative 6 over here. Divide by 6. X equals negative 1. Done. Okay. I don't have to check this one. I don't have to check my answer, plug it in, because we can have exponents, we can have positive exponents, negative exponents, fraction exponents. You've seen them all, and you will see them all on the test next week. We've seen them all. We've taken quizzes, we've had delta math assignments where we've had negative exponents, fraction exponents, negative fraction exponents, 0 exponents, right? You've had all of those. So these are okay. We don't have to check them. We don't have to check that answer. We're done. Okay. All right, now let's look at the next one. Okay, 16x minus 2 equals 32x plus 3. Okay, so 16 and 32 are my bases. So the first step I have to do is figure out what base they have in common. Now again, I'm not talking about a GCF. A lot of people say, I've heard this a lot, 16. 16 to the first power makes 16, but does 16 to any power make 32? It's way too big. So it's not going to be 16. So what to what power is going to make 16 and 32? 2, yeah, it's going to be 2. Yeah, because 16 is 2 to the 4th power. 2 times 2 times 2 times 2 is 16. And 2 to the 5th power is 32. 2 times 2 times 2 times 2 times 2. So their common base is 2. Okay, bring everything else down. Once you know what their common base is and you've rewritten it, again, 16 is the same as 2 to the 4th. If you were to go in your calculator and say 2 times 2 times 2 times 2 times 2, you get 16. And if you were to go to your calculator and go 2 times 2 times 2 times 2 times 2, you get 32. So I didn't change the number, they just look different. Okay, so now get rid of the parentheses. Distribute, distribute. So we get 2 to the 4x minus 8, and we get 2 to the 5x plus 15. No more parentheses. I know what the common base is. So if the 2's are equal, that means the exponents also have to be equal. That's my last step. Set them equal to each other and solve. There's no squared, so I don't have to set them equal to 0. I have to get x's on one side, numbers on the other. Subtract 4x from both sides. One x plus 15 minus 15 from both sides. X equals negative 23. Okay, so those are the 3 steps that we're going to use to solve these types of problems. Exponential equations, equations with exponents instead of logs. Okay, there's one more problem I want you to do in your notes. I didn't have room to put it on the sheet, so wherever you're going to tape it in, let's do this problem. One more problem in your notes, and then we'll move on. Okay. Okay, so let's see here. Okay, so last one we're going to put in your notes. Okay, so same steps. We're not changing the steps. I'm not changing any of the steps, but what's the difference? One of them is a fraction now. Yeah, one of them is a fraction. So this is what happens when you do a fraction. Focus on the number, not the one part. Don't focus on the one part. Focus on the number here. That's what we're looking for common bases. Okay. So 16 and 128. What bases, big numbers and exponents, do they have in common? So 4, let's see, could be 4 to the second power makes 16, right? Does 4 to a power make 128? Let's see, 4 squared is 16. 4 to the third power is 64. 4 to the fourth power is 256. Now it's too high. Close though. I think we're going to use 2 again. We already know what 2 to the, so 16. So 2 to the, let's see, 2 to the seventh power is 128. So 2 to the seventh power. 16 is 2 to the fourth power. But how do I write it? Negative. Yeah, negative power. Why is it a negative power and not a positive power like all the other ones have been? There you go, because it's under 1. I got to move it up. To move it up, no more fraction now. There's no fraction in there now. All right? No more fraction, so I had to move it up, and it's 2 to the fourth. Or, sorry, 2 to the negative fourth. Good. That's the hardest part about today's. If you can do that, chances are the rest of the steps you're going to do correctly because you've done them before. Okay? The next step, once I get my common base is going to be 2. The next step is distribute the powers. So I'm going to distribute negative 4 here, distribute positive 7 there. We have 2 to the 20x minus 12 equals 2 to the 7x minus 7. Okay. The bases are already the same. We know that too. So if the bases are the same, that means the exponents have to be the same as well. Okay. Set it equal, or subtract 7 from both sides. Add 12 to both sides. Yes. I always do that to keep it positive, to keep the number in front of x positive. You don't have to, but the way I do it, I guess that's just the way I was taught. Um, yeah, whatever you want to do. Yeah, whatever you want to do. You'll just have a negative number for x. That's fine. You just divide by a negative number at the end. It's not wrong. So last thing is divide by 13. Divide by 13. Uh-huh. 20x. I see 20x. Yeah, -4 times -5. Yeah. No, thank you. Yeah, because I'll make mistakes. So please, if you see something right or wrong, let me know. Okay. Okay, so it's not a nice, pretty answer, right? 5 over 13. If you put it in your calculator, watch, let's put it in our calculator. Let's put it in our calculator, see what kind of answer we're going to get. It's not going to be a pretty answer. It's going to be a decimal. 5 divided by 13. Ugh. My calculator stopped writing numbers after the 2 at the end. It keeps going, okay? And it doesn't repeat it all. So I don't want to change it to a decimal. I don't want to change it to a decimal because then that rounds it. And it didn't say round in the question. So what am I going to do? I'm going to do two things. I'm going to try to reduce it. Can I reduce 5 over 13? Nope. Once you do that, leave it the way it is, 5 over 13. Don't change it to a decimal. Unless they specifically ask you in the question, round your answer. Okay? We don't want to round unless they tell us to. Okay? Because once you round it, it's not the exact answer anymore. Mm-hmm. Sure, yeah. All right. All right.